Hey, my mathematical geniuses. Welcome to lesson 2 of our last unit, uh, integral calculus. Yesterday was kind of a long one, and it was because I did 6.1 and 6.2 together. So now we're on 6.3 for lesson 2, which is going to deal with the integral symbol and substitution. You'll recall that yesterday there was 2 questions that in order to figure out the antiderivative, we kind of had to guess and check our way into it, just using some logic of how to take the derivative and kind of working backwards from there. That's fine and dandy, but those were simple ones to do that with. And obviously we're going to get more complicated. So what we want to do today is we want to look at a method of substitution to help us arrive at the antiderivative in a more succinct manner. Okay. First of all, though, I need to introduce this symbol to you that you see in red there. My big old head is probably in the way for some of you, so I'll cancel my head for a second. This symbol right here is what we want to talk about, okay? And that is called the integral symbol. Okay, so we say that big f of x is an antiderivative of little f of x if the derivative of big f of x is equal to little f of x, which means f prime, big F prime of x, the derivative of f of x, the derivative of big F of x will be little f of x, okay? And yesterday we called that the indefinite integral, okay? We called it the indefinite integral because we had that plus c, and c really could be anything until we had a context, okay? So the indefinite integral is the most general antiderivative of big F of x on an interval. And it's denoted by this, and we say the integral of f of x, okay, equals big F of x plus c. So I need to unpack this symbol here for a second. And what I want you to first of all note before I switch the slide is this, okay? That together means the integral of whatever's in the middle, okay? They're not two separate things. They are the integral symbol, and then in between them, we put what we're taking the integral of, okay? So I'm just gonna switch the slide here and clear my ink. So note, that is one symbol, not two, okay? The integral sign and the dx sign have no meaning by themselves. Rather, they're associated with each other and mean the indefinite integral of, okay? The indefinite integral of. Okay, so earlier in this unit, we found that the antiderivative of f of x equals x cubed minus 2 all to the 4 times x squared was big F of x equals 1 over 15 x cubed minus 2 to the 5 plus c. And if you'll recall, I kind of did a guess and check method over on the board with you for that one, okay? The method in which we came to the answer was a bit of logic and guesswork. So now we're going to try and find the antiderivative for more complex functions where the product and quotient law is involved, and we're going to do it by a process of substitution. I alluded to this yesterday. You've done something like this similar before, so hopefully some of it's going to feel very familiar to you, okay? You just have to wrap your mind around a couple of tiny details and then you'll be good. Okay, so we're going to do that same question, but we're going to do it through the process of substitution. So what we're going to do is we're going to substitute x cubed minus 2 to the 4, or x cubed minus 2, sorry. We're going to substitute x cubed minus 2 as u. Okay, so I took this guy and I'm substituting it as u. Now, what would be the derivative? Now, the derivative would be du over dx, because it's the derivative of u in terms of x, okay? And that would be 3x squared. Okay, so now, here's where it gets kind of interesting, and this is, you got to wrap your head around it for a second. This says the derivative of u with respect to x equals 3x squared. I would like to now rearrange that statement so that I have dx by itself, okay? If I wanted to have dx by itself, essentially du divided by 3x squared would be dx, okay? Which means 1 over 3x squared du would be dx, okay? I've just made an algebraic switch there. I've just manipulated what I was looking at. If du with respect to dx is 3x squared, then I can divide both sides by 3x squared and get 1 over 3x squared du will be 1 dx, okay? Why would I do that? Well, stay with me. Now I'm going to take the integral. So I've been asked to take the integral of f of x, where f of x is x cubed minus 2 all to the 4 times x squared. So big f of x will equal the integral of x cubed minus 2 all to the 4 times x squared. Now, here's where the substitution comes involved, okay? I want to substitute this with u, okay? But then if I want to have this as u, I need this to say du, not dx. Well, actually, I'm ready to do that because I'm told that 1 over 3x cubed du is the same as dx. So I can take my dx and substitute it with that at the same time that I take my x cubed minus 2 and substitute it with u. Okay? So what would that look like? Well, let me clear the ink and show you. So the first thing I did was the u substitution, and now I'm going to do the dx substitution. You can do it all in one step. I'm just trying to show you what I've done, okay? So now I get a statement that reads, big f of x is the integral of u to the 4 x squared times 1 over 3x squared du. Now that worked super good because I can't have multiple things going on here, like multiple different variables going on. But I don't anymore because my x squares divide each other out and I'm left with 1/3 u to the 4. Okay, now that 1/3 is just a coefficient, so it can come to the front of the integral sign. And I'm left with big f of x is 1/3 the integral of u to the 4. Well, now I'm back to what I did yesterday. The integral of u to the 4 would be, this is going to go up a degree, so that'd be 5. And then I have to take my coefficient and divide by 5. 1/3 divided by 5 gives me 1 over 15. So big f of x is 1 over 15 u to the 5 plus c. Then final step is I put u back to what it was. Okay, and u originally was x cubed minus 2. So my antiderivative is 1 over 15 x cubed minus 2 all to the 5 plus c. And that's exactly what I got yesterday, okay? So that's what we're going to practice today. We're just going to go over this a couple of times with a couple of different equations, and hopefully you'll feel really good. Okay, in the next example, we have little f of x is 2x plus 1 times x squared plus x plus 5 all to the 17. And now we need to decide, okay, who's going to be u? Now, there's a couple of different thoughts here. Number one, usually you want to make the most complicated one u. But number two, you also want to notice that you want it to be a friendly derivative, okay? And what I mean by that is if I took a look at x squared plus x plus 5 and the derivative of that is 2x plus 1, and that speaks to me that that would be super friendly to deal with, okay? So I'm going to make u x squared plus x plus 5. So the derivative of u, du over dx, would be 2x plus 1, okay? Now I rearrange that so that I get dx by itself, so I can, when I go to make the u substitution, I have a dx substitution as du as well. So that'd be 1 over 2x plus 1 du equals dx. Okay, so now I'm ready to do the substitution and then the integration. So big f of x is the integral of 2x plus 1 times u to the 17 dx, and then I'll substitute out the dx with 1 over 2x plus 1 du. Now, again, that was super friendly. Everything worked the way I wanted to because my 2x plus 1s are gone, and I'm left with u to the 17 du, and I can actually take the integral of that. Okay, sorry, I lost my mouse because it's got an ink on. There we go. Okay, so the integral of u to the 17 du. So the 17 has to come up to be an 18, which means I have to divide my coefficient by 18. My coefficient right now is 1, so that'll be 1 over 18 u to the 18 plus c. Then I just put u back. So u was x squared plus x plus 5. So I get 1 over 18 times x squared plus x plus 5 to the 18 plus c. Okay, easy peasy. You guys got this. All right, so the substitution rule for indefinite integrals says the following. If u is g of x, then the integral of f of g of x times the derivative of g of x dx will be the integral of fu du, okay? So let u be the inside function of the composite function. This is the counterpart. Counterpart means like the other direction to chain rule with differentiation, okay? All right, so determine the following. Well, who's u? U is going to be x squared plus 5x plus 8, okay? Partly because I can see right away that the derivative of x squared plus 5x plus 8 is 2x plus 5, so that's going to make me feel good about life, okay? So u is x squared plus 5x plus 8. I need to take the derivative. That'll be 2x plus 5. Then I need to rearrange that so that I have dx by itself. That'll be 1 over 2x plus 5 du. And now I'm ready to do the substitution. Okay, so big F of x will be the integral of 2x plus 5 times u to the negative 1/2. I got to swap out my dx for du there in order for this to work. So I can do that because I know that dx is 1 over 2x plus 5 du. Okay, and so then my 1 over 2x plus 5 plus times my 2x plus 5, they divide each other out, and I'm left with u to the negative 1/2. When I go to take the integration of that, negative 1/2 goes up to positive 1/2. I take my coefficient, which is currently a 1, divide by 1/2, and that'll be 2. So I end up with 2 u to the 1/2. Then I put u back. U was x squared plus 5x plus 8. So I'm looking at 2 root x squared plus 5x plus 8 plus c. Okay. Awesome. Okay, try this guy. The integral of 6 root of x cubed minus 8 times x squared. Okay, so my u will be x cubed minus 8. The derivative of that will be 3x squared. Switching that up, I could end up with dx will equal 1 over 3x squared du. And I'm ready to do my integration. Okay, so big F of x will be the integration of 6u to the 1/2, that was for the square root, times x squared dx. I'm going to swap my dx out with 1 over 3x squared du, which means my x squares are gone, but my 1/3 isn't, so that'll be 6 times 1/3, which will give me a 2. Okay, so I end up with 2 u to the 1/2, and I'm going to take the integration of that. So 1/2 goes up to 3 over 2, which means I have to take the 2 and divide by 3 over 2, which will give me, that's the same as saying 2 times 2 over 3, so that'll be 4 over 3. So I end up with 4 over 3 u to the 3 over 2 plus c. Okay, so now I just have to put u back. And I end up with big F of x is 4 over 3, x cubed minus 8 to the 3 over 2 plus c. Okay, so now I want the integral of ln x over x. So I'm going to make my u be ln x. The derivative of ln x is 1 over x, so du over dx will be 1 over x. I want to switch that to be dx equals. So dx equals x du. Okay, I multiply both sides by the x and then multiply both sides by the dx. Okay, so big f of x will be the integral of u over x, but again, I have this problem right now because I have it as dx. I need to switch that to du, but I know that dx is x du, and then that will divide my x's out, so I'm just left with the integral of u. Now, that's u to the 1. If I want to bring that up to 2, I have to divide my coefficient by 2, so that'll be 1/2 u to the 2. So big f of x equals 1/2 u squared plus c, and then I put u back, u being ln x. So I have big f of x equals 1/2 ln x all squared plus c. Okay? Okay. I've got the integral of e to the 2 root x all over root x. So my u, I'm actually going to make being 2 root x for this guy. Okay, so I'm going to call that, so u equals x to the 1/2. Sorry, 2x to the 1/2. U equals 2x to the 1/2. I forgot the coefficient of 2 there. So du over dx, 1/2 comes to the front, so that'll equal x to the negative 1/2. Which means dx will equal 1 over x to the negative 1/2 du. But 1 over x to the negative 1/2 is just x to the positive 1/2, right? Because the negative on the bottom will flip it back to the top. So dx will equal x to the 1/2 du. Okay, so big f of x will be the derivative, or sorry, the integral of e to the u divided by x to the 1/2 dx. I swap out my dx for x to the 1/2 du, and my x to the 1/2s divide each other out. So I'm left with big f of x is the integral of e to the u. And I know that the integral of e to the u is e to the u. So I have e to the u plus c, and then I put u back. So big f of x will be e to the 2 root x plus c. And again, if at any point in time you don't believe me or you don't believe yourself, take the derivative of this and you'll get back to where you started, right? If I want to take the derivative of e to the 2 root x, well, the derivative of e to the 2 root x will be the derivative, where it'll be e to the 2 root x times the derivative of the inside function. Well, the inside function is 2x to the 1/2, and that would be x to the negative 1/2, right? And so that would give me e to the 2 root x all over the root of x, which is exactly what the question started with, okay? So when you're ever in doubt, check yourself out. The integral of the root of sine x times cos x. So for my substitution, I'm going to take u and call it sine x. I know that the derivative of sine x is cos x, which then also means if I want to rearrange this so that dx is by itself, dx will be 1 over cos x du. Okay, so I go to start my integration. So big f of x will equal the integral of u to the 1/2 times cos x. So u to the 1/2, my sine x was u, and then the root became the exponent of 1/2. I'll swap out my dx. Dx is going to be swapped with 1 over cos x du, and so my cos x will divide each other out. And I'll be left with just u to the 1/2. So I'm looking at the integral of u to the 1/2. The 1/2 has to go up a degree, so that'll be 3 over 2, which means I need to take my coefficient of 1, divide by 3 over 2, which is the same as saying multiply by 2 over 3. So I'll have 2 over 3 u to the 3 over 2 plus c, and then put your u back. So 2 over 3 sine x to the 3 over 2 plus c will be the antiderivative. Okay, so that's what we're working on today. Here is your task. And as always, please connect with me if you have any questions. You got this, guys. Go for it. Take care.